This video will explore our third point of concurrency for a triangle called the incenter. Now the directions here have a typo in them. It says to use your compass and straight edge to construct the angle bisector of each, and it should say angle of the triangle below. So just like each of the previous videos that dealt with points of concurrency, this one too is going to require the use of your compass and straight edge. So let's go ahead and grab our compass and straight edge, and we're going to jump right in and start by constructing the bisector of each angle. So I'm going to go first of all and put the point of my compass on point or vertex B and construct the bisector of angle B. Next, I'm going to go ahead and construct the bisector of vertex A. And then lastly, I'll go ahead and construct a bisector of angle C. And if done carefully and precisely, all three of your angle bisectors should end up at one point called the incenter. Now notice that mine all meet together at a little triangle rather than at one point, and that's because I probably wasn't as precise with my constructions as I could have been. So that point there where the three angle bisectors of a triangle meet is called the incenter. So down at the bottom, I'm going to go ahead and define that as the point of concurrency. Remember that a point of concurrency is a point where three or more lines intersect. And what's so neat about the incenter is that the incenter is equidistant from each side of a triangle. So in other words, if I head back up and I name my incenter point X, then the distance from point X to side AC is exactly the same as the distance from point X to side BC, which is exactly the same as the distance from point X to side AB. And we can use this property to do something very unique and very special. Because the distance from our incenter to each side is exactly the same, we can grab our compass again and we can draw what's known as the inscribed circle of a triangle. Now, the inscribed circle of a triangle is going to be the circle whose center is at the incenter and whose radius length is going to be equal to that of the distance between the incenter and the side. This is going to be an approximate construction, not an exact construction, because number one, my incenter is not exactly exact. And number two, we would have to do the perpendicular distance from that point to each side, which I haven't shown you how to do yet. But we can have a little fun and at least do an approximation. So I'm going to use my compass to just measure a little bit here. And get, again, an approximate distance from that point to each side. You may have to experiment with this a little bit so that it ends up as accurate and as precise as it can. I'm going to go ahead and extend that compass setting just a wee little bit more. And then I'll go ahead and sketch my inscribed circle. And again, that inscribed circle is the circle that exactly fits exactly inside so that it bumps up against each edge or each side of the triangle. So my inscribed circle would be the circle that I just put in the picture there in pink polka dots. All right, that will call it a day as far as the incenter. I want you to take a minute now and reflect upon what you think are the most important and key ideas of this video. What would be the purpose in making you watch this or having you watch this? What did I want you to get out of it? Once you've taken that time to reflect and think about the key ideas, if you have questions, go ahead and jot them down in the margins and we'll talk about them the next time you come back to class.